The objective of this lesson is to generate equivalent expressions using the distributive property. Equivalent expressions are two expressions that yield the same result regardless of the number used for the variable. Let's begin by looking at the following area model. The multiplication problem for this area model is 6 times 8. How is 6 times 8 solved in this model? Notice on top of the model, the 8 is decomposed into the addends 2 and 6, which added together equals 8. This model is known as the distributive property. When one of the factors of a product is a sum, multiplying each addend before adding does not change the product. Let's look at how using the distributive property can help us find an equivalent expression for 4 times parentheses x plus 3. We will begin by drawing an array to represent the expression 4 multiplied by the sum of x plus 3. We will use the algebra tiles to represent x and unit cubes to represent the numbers. Place one column of 4 x tiles vertically and 3 columns of unit cubes vertically. We have 4 groups of x's and 4 groups of 3. This would be written as parentheses 4 times x plus parentheses 4 times 3. Another way to model the arrays are with the box line dot method. We will use the box line dot method to draw the array for the following expression, 6 multiplied by the sum of x plus 4. The lines represent a variable or unknown quantity, and each dot represents 1. We need to fill in the array with 6 rows of x plus 4. Each x is represented by a horizontal line. The numerical value is represented by dots. We will add 4 dots to each line. If we combine like terms, we now see we have an array that represents 6x plus 24. Notice when we apply the distributive property to generate an equivalent expression, the 6 outside the parentheses is multiplied by the x to equal 6x, and the 6 outside the parentheses is then multiplied by the 4 to equal 24. The new expression is 6x plus 24. Let's now draw an array to represent the expression x multiplied by the sum of 3 plus 2. We will fill in the array with lines to represent the variables. The first factor of 3 is represented by 3 vertical lines, and the second factor of 2 is represented by 2 vertical lines. The equivalent expression represented by the array is 3x plus 2x. When we apply the distributive property to generate an equivalent expression, the x is multiplied by the 3 to equal 3x, and then the x is multiplied by the 2 to equal 2x. 3x plus 2x is equivalent to the expression x multiplied by the sum of 3 plus 2. The objective for this lesson was to generate equivalent expressions using the distributive property. We met this objective by drawing array models and applying the distributive property in expressions.